Section 4.2 is all about building linear models from data. So if you've taken statistics before or done or remember something called linear regression, you're a little bit ahead of the game. So what I have to work with when I'm making mathematical models using visual data is typically a scatter plot, right? I'm comparing two different data. So I've got our x-axis, that's for our independent variable, and our y-axis, that's for our dependent variable, right? And I'm going to plot all these coordinate points on our graph. It'll look something kind of like this. Note, I'm not connecting them with lines, right? We're just graphing the individual points. Because if I connected them with a line, it would look like really weird, right? It'd be all like zigzaggy, and that doesn't tell us anything. So we don't want to do that when we're graphing scatter plots. So for example, how do we create a scatter plot for weight and price of diamonds? So here's some actual legit data, right? And of course, we would expect a diamond's price to depend on its weight, right? We would expect those two things would be related. The more the diamond weighs, the bigger it is, the more it's going to cost. Let's take a look at that scatter plot. So here we have a graph of the scatter plot of our different weights of diamonds and their price in dollars, okay? So you can see that we wouldn't want to connect this data with a bunch of squiggly lines, but you can kind of see how one could maybe envision a line that would go through this data and would be as close to those data points as possible. That's an example of linear regression, and that's the point of this section. Ta-da! Okay, so let's talk about the different types of correlation first. So if I have a scatter plot, right, the first type of correlation is positive correlation, right? This is when our data appears to take on a value that would appear to have a best fit line that would have a positive slope, right? And we have a correlation coefficient. That's something that is calculated for us. You will never have to do it by hand because I had to do it in college and that was mean. So I'm going to show you guys how to calculate a correlation. And your correlation becomes stronger as your points get closer and closer to the line. So see how in this first example, they're more spread out. And so I've got a tiny correlation coefficient. And then they start to get closer together. And then when they find a perfect line, it equals 1, right? That's the most perfect correlation. Our correlation coefficient R only goes between 1 and -1 because other than positive correlation, we can have negative correlation. So negative correlation is when our y values go down, as our x values increase, and our best fit line would appear to have some negative slope, right? So if it's a really weak correlation, my points are really far away from my best fit line right here, that's going to have a small number like 0.3. As I get closer and closer together, that number is going to get closer to -1, which again represents perfect correlation. Now, if you're using real life data, you should never have perfect negative or perfect positive correlation, okay? Also, you could have no correlation. This isn't like constant correlation. We don't do that. It's kind of like constant correlation, right? There's no relationship. We'd have R is 0. Friendly reminder, R does not equal slope, okay? Our best fit lines through a data set will have a slope of their own, and it's not going to be R. And lastly, we can also have nonlinear correlation. This correlation takes on kind of a parabola shape. I could also have some data that would take on, maybe more of like a up and down. This would definitely not be linear, right? Because it's got a lot of curves to it. Okay, so nonlinear data doesn't follow a straight line. So, types of correlation. Like I said, we've got positive correlation, negative correlation, no correlation, or nonlinear correlation. Remember, any graph that is not a linear function is nonlinear. We talked about that in section 4.1. So how do I measure the strength of a correlation? Well, I had mentioned this correlation coefficient R. So we measure the strength of a correlation with our correlation coefficient R that will be calculated for us. The correlation coefficient R is a measure of the strength of our correlation, and it can only be between -1 and 1. -1 means perfect negative correlation. +1 means perfect positive correlation. Perfect correlation should not happen in the real world. Next, if there's no correlation, the points don't follow any kind of straight line pattern, so our value is close to 0. There's strong correlation. Strong correlation would be really, really close to 1. Weak positive correlation would be really, really close to 0. We can also have strong negative correlation. That number would be really, really close to -1. And weak negative correlation would be really, really close to 0. So on a scatter diagram, our best fit line, also known as the regression line, is the line that lies closer to the data points than any other possible line. And this is according to like a statistical measure of closeness. It's an ugly looking formula that we won't have to use because we're going to find our best fit lines on our graphing calculators or in Desmos. So how do I find the best fit line in Desmos? So what you can do is you can insert a table and input your ordered pairs. You can even copy this from a spreadsheet or in Excel if needed to be. You're then want to type y1 tilde mx1 plus b. This tells Desmos to give you the best fit line. It's important to note though that your table needs to have the values x1, y1, and that'll be generated automatically, and that these have to match. If you try and do a second problem, it'll generate another table of like x2, y2, and then you just have to change this equation to y2 tilde mx2 plus b, okay? This Desmos is going to return information for you. It's going to give you your R coefficient, your slope, and your y-intercept because R and slope are not the same. So let's work through an example. I pre-prepared. And we magically go to Desmos. So what did I do? So I wanted to go ahead and I entered in this data, and this data is about the hours of video games you play and your GPA. So then I go in and I typed in y2 tilde mx2. Here, let me get rid of this so we can type it in ourselves. And I typed in y2 because I had x2 and y2 in my table. So I've gone ahead and plotted this data. I then type in y. I only need one y. Let's try that again once I get my keyboard open. Y sub 2 tilde, but that tilde has to be up, tilde mx sub 2. See, we're starting to graph our line. Now I've got a slope, but I need to add my b. And there we have our best fit line. So here's our data, and this is the line that would be closest to our all of our points. Our R is -0.86. This makes sense that we have negative correlation because our graph looks like it's going downhill. And then our slope is -0.09. So we've got a really, really weak slope, and that's cool, but we've got a really strong correlation. And my y-intercept is 3.276. Okay, so here's my beautiful line. You can graph points on our line. So Desmos is one way I would recommend graphing linear regression. As for my Math 1200 college algebra class, you will not have to do this on an exam. It is time consuming, and it shows how good you can use technology, not how well you can use your brain. So this will not be on an exam, but you do need to know how to do this for the homework. So let's go back to our PowerPoint, because I talked about how to use Desmos, but I didn't talk about how to use your graphing calculator. And that's because there's a video. There's a video that someone made that's much better than a video I could make while I'm trying to film with my phone, me on my graphing calculator that I got at a yard sale. So if you have any questions on or issues graphing on your graphing calculator, feel free to shoot me a message. But my recommendation again is Desmos. Friendly reminder that Desmos is also an app you can put on your phone. Be cool and have one more calculator on your phone.